Hello, friends. So, today we are going to have a new chapter that is the consolidation settlement. So, the chapter is uh, related to consolidation settlement, and this is the great problem of 2024 set 1. The problem is like this: the primary consolidation settlement SC of a building on 10-meter thick saturated clay layer is 50 millimeter. So, if you look to the solution part of this problem, the total consolidation settlement is given to you as 50 After 300 days, so time is given. So, time is 300 days. So, after 300 days, the primary consolidation settlement SC, let's say this is T1. So, SC1 after 300 days is going to be 10 Find the additional time required to achieve 50% of SC. Now, you see, you need to find out the time required, T, to achieve 50% of the total settlement. What is the total settlement? It is given as 50 And T1, for T1 equal to 300 days, SC1 is given to you 20 So, SC1 divided by SC, that is the degree of consolidation, is going to be 10 out of 50 into 100. So, this is the degree of consolidation. So, what is that? This becomes 5. So, this becomes, so U becomes 20%. So, for U equal to 20%, you know the time factor, or you know the value of CV. CV equal to time factor into d squared divided by t. So, here the value of CV multiplied by t divided by d squared will be the value of TV. Therefore, this implies that TV equal to CV into T divided by D square. That is the time factor. Now, for U equal to 20%, the time factor TV equal to U pi by 4, that famous formula, you know it, divided by into U by 100 whole square. So, the time factor will be equal to pi by 4. And what is the value of U? U is 20%. So, it is 20 divided by 100 whole square. So, time factor becomes TV equal to pi by 4 into, this becomes 2 by 10 whole square. That means it becomes 4 by 100. 4 goes out. So, this becomes pi by 100. So, TV for T1 equal to this, you can say it is TV1 and U1 is 20%. So, this is U1 equal to 20%. So, this is pi by 100. So, what is the formula for TV? This is the formula. So, therefore, pi by 100 that is TV1 equal to CV multiplied by time. Now time is given to you as 300 days divided by d square. So this is 1. This is given to you. Now, in the if you look to this problem, then find the additional time required to achieve 50% of SC. So for 50% of SC, when u equal to, for u equal to 50%, time factor TV 2 equal to pi by 4 into 0.5 whole square. So this becomes pi into 0.25 divided by 4. So TV2 will be equal to CV into T. So now here it is going to be CV. For the same clay, there is no change in the coefficient of consolidation, CV. So coefficient of consolidation, CV, remains same. Time T2, you have to find it out. So you will have to find out the time required to achieve 50%, additional time required. So CV into T2 divided by d square. So this becomes, or we can say TV2 is already taken as how much this is, 0.25 times pi divided by 4 equal to CV into T2, which we want to find it out, divided by d square. Now from 1 and 2, we know that pi by 100 equal to CV by d square into 300, and from this is 0.25 times pi. So the ratio of the two, if you take it, it becomes like this. So therefore TV2 divided by TV1, so TV2 is can be written as 0.25 pi by 4, and TV1 is pi by 100, isn't it? Pi by 100 equal to TV2 is given by CVT2 by d square, drainage path, where d is the drainage path, which remains same, divided by TV1 is given over here as TV1 equal to CV into 300 days divided by d square. So therefore, the ratio of 2 by 1, that is 2 divided by 1, gives you this value. So CV gets cancelled. This d square goes out. Therefore, you can find out T2, that is the time required to achieve 50% of SC. So 50% of SC, you can find it out. So U is 50%, and therefore here T2 becomes 300 multiplied by this. You can simplify it. So 0.25, let's simplify it, calculate it. Pi goes out, and this becomes 25. So you can just see the calculation for T2 equal to 300 multiplied by 0.25, and into 25, right? So if you multiply it and simplify, what is the value? Let us see that. So 300 multiplied by 18,1875 days. So now here the word is additional time required to achieve. Already for 10% you have taken how many days? 300 days. So after 300 days you have achieved 20%. So for going to 50%, you require, the number of days required are 1875 days. Therefore, you can find out the additional time required to achieve 50% settlement will be 1875 minus 300. So it becomes 1575 days. So the answer, the additional time required to achieve 50% of SC, additional time is going to be 1575 days. So this is the answer of this problem. So very important formula, you should know the time factor. The time factor depends upon the value of CV, that is coefficient of consolidation, and you can also, it depends upon T, and it depends upon drainage path. So you can find out the value of time factor, and because it is going to be same clay, so CV doesn't change over here. Only drainage path is going to be same. Whether it is single drainage or double drainage, drainage path will not change. Only degree of consolidation is going to change, and therefore for different degree of consolidation you can find out the time period. And once you know the time period, you know the relationship between the time period and the value of coefficient of consolidation, and the required time and drainage path. So this is how you can attempt this problem. I hope you all have understood in totality this particular problem. Now I will be taking the next problem. In consolidation of the clay soil, uh, I have my previous videos where I have talked about how to find out the consolidation settlement for normally consolidated clay, how to find out the consolidation settlement for over consolidated clay. So my videos are there that you can refer to. All those theory I have talked about in my past videos. So if you look to this channel, you will be getting how to compute the consolidation settlement, how to calculate the time period, how to calculate the coefficient of consolidation, and all those theory is already explained. So I will be taking another gate problem, 2022 gate problem is there. We can see the figure here. This is the ground level and you have got sandy ground. So this is the sandy ground and you have a raft. In the sandy ground, the raft is the base of the raft is at a distance from the ground level 8 meter. So this is the raft which is embedded in the sandy ground as shown in the figure, and the base of the raft is at a distance of 8 meter, and this remaining 2 meter, this sand only. This is also sand. So this is sand, this is also sand, and then followed by you have clay layer. So now you have got clay layer. So from here up to here, this is the clay layer, followed by again sand. And the dimension of the raft is 30 meter by 25 meter. So this raft is 30 meter by 25 meter. So the pressure bulb is going deeper, and the clay is going to be compressed, and the settlement here is consolidation settlement. The given data for this are for the raft, for u equal to 25%, the degree of consolidation u equal to, so for u equal to 25%, calculate 25% of the total settlement. You need to calculate the time required. Calculate the time required. Now, if you collect, a sample has been collected from the center of this clay. So a clay sample has been collected for laboratory investigation or laboratory tests, and the thickness of this sample is 25 mm. So you have collected from the center of this clay, and the thickness is given over here, and the test, consolidation test, has been carried out for double drainage, because you have got sand at the top of the clay and bottom of the clay. It will lead to double drainage. So in the consolidation test, the uh, double drainage consolidation test has been performed, and uh, for u equal to 50% of consolidation settlement, for u equal to 50% of consolidation settlement, the time required T is 10 minutes. So for u equal to 50%, you can you have this much of data available with you. So from this data, from the given information, from lab test data, we can go for the solution of this problem. So from lab test data, the value of u equal to 50%, therefore time period TV equal to pi by 4 into 50 by 100 u by 100 whole square. So this becomes 0.5, 50 by 100, and if you square it, this becomes 0.25. Time factor. Now you know that time factor TV is known to you from the relationship that CV equal to time factor into d square divided by t. So TV will be CV into t by d square. So the time factor TV for 50% consolidation settlement will be equal to CV into time is 10 minutes divided by d square. And D is, because it is double drainage, which is given over here, so it will be H1 divided by 2. So it is going to be equal to CV into 10 divided by 25 divided by 2, that is 12.5 whole square. Now what is the value of TV? TV is 0.25 times pi by 4 equal to CV into 10 divided by 12.5 whole square. This is in millimeter H. So 25 millimeter divided by 2 for double drainage. So and time is in minutes. So the value of CV from this will be in millimeter square per minute. So you will have to simplify this one, and you will be getting the value of CV for the clay soil mass. So from the lab test, I am able to get the value of coefficient of consolidation. So let me calculate 0.25. So the value of CV comes out to be here 3.0679 67 up to 3 decimal places millimeter square per minute. Let me check once again. 3.067 millimeter square per minute. So value of CV from consolidation test, I am able to find it out. Now come to the this for the raft. For the raft, the degree of consolidation is 25%. So for 25%, the time factor TV will be pi by 4 into 25 divided by 100 whole square. So if you simplify it, this is going to be pi by 4 into 1 divided by 16. So it is pi by 64. So what you will have to find out is time. Calculate the time required. Calculate the time required. So now TV we already know. TV will be equal to, so for this problem, the time factor is given as coefficient of consolidation into time required divided by drainage path whole square. Now, the this we will have to find it out. Time factor you have already calculated. CV you have already calculated. And the drainage path for the in situ condition or site condition, the value of clay thickness is 25 meter, and therefore D will be for double drainage 25 divided by 2, that is 12.5 meter. So D is also known to you. So what is unknown is only T. Therefore, T equal to TV multiplied by drainage path whole square divided by CV. So if I substitute the value, TV is pi by 64 and drainage is 12.5 whole square into CV value is 3.067. So the time will be in minutes. If you simplify it, you get the answer in minutes. So let's calculate it. So 3.067 multiplied by 64 in the denominator equal to this, and then we can calculate the numerator and shift this multiplied by, so 64 into this, and in the numerator it is into pi multiplied by 12.5 square. So the time in minutes should be okay. So you can find out the time. So once again I will check it. Zero minutes. So you will have to simplify it and get the value. So I have shown you the techniques which you can from lab test how to compute the value of coefficient of consolidation, and because the sample is from the site, the CV remains unchanged. So you can substitute for the site condition the value of CV from the lab test, and then you can find out the value of T by knowing the drainage, etc., and calculating in the respective units. So this is how you can do it. So the simple way we can calculate it without much of the problem, and the solution can be found out. I hope these problems conceptually you are able to understand. Now, we will take the next problem, that is 2021. So, this is also important gate problem that we can see it. The void ratio of a clay sample M decreases from 0.575 to 0.510. There is a change in void ratio for sample M when the applied pressure is increased from 120 kilopascal to 180 kilopascal. So the increase in pressure, delta sigma prime, is known to you, delta E is known to you. The change in void ratio for sample M, and for same increment of pressure and for the same increment in pressure, that is from 120 to 180, same increment in pressure, the void ratio of another clay sample, the void ratio of another clay sample N. So another clay sample is N, decreases from 0.600 to 0.550. So here the change in void ratio and change in pressure is also known to you. If the hydraulic conductivity, if the hydraulic conductivity of sample M to N M to sample N is 0.125, then the ratio of CV, that is coefficient of consolidation, of sample M to sample N M to N will be dash. So you will have to find out the ratio of coefficient of consolidation for sample. Now you see the solution. Solution is going to be again quite simpler from the given data. So if you see the solution part now, I will take first the sample M. So if I take sample M, I can find out the value of MV for sample M. What is the formula for MV? You know it. That is going to be coefficient of compressibility AV divided by 1 plus E naught. And what is coefficient of compressibility? It is the change in void ratio per unit increase in effective pressure into 1 upon 1 plus E0. This is the value of MV. So friends, you can calculate this. What is delta E? For sample M, the value of delta E, you can calculate it as 0.575 minus 0.510. What is delta sigma prime? It is 120 to 180. So 180 minus 120. And what is the value of E naught? 1 upon 1 plus E naught. What is the value of E naught? This is your E naught value given in the problem as 0.575. So it becomes 1 plus E naught becomes 1.575. This is the value of MV. And what is the unit of MV? It is the unit of sigma prime. So it is in the denominator. And what is the unit of stress? It is going to be now, what is the unit over here that you can see, kilopascal. So it is going to be opposite kilonewton per meter squared. So it will be meter square per kilonewton. So MV1 is known to be, and similarly, I can simplify this. So if I simplify it, let me calculate. I am getting it 6.878 into 10 raised to minus 4 meter square per kilonewton. It's very nice. Similarly, I can find out MV value, coefficient of volume compressibility for N. So it will be delta E. Now for N, the delta E is going to be 0.6 minus 0.55 delta E divided by delta sigma, that is 180 minus 120, that is 60, multiplied by 1 upon 1 plus E naught. The value of E naught here for sample N is 0.6, so this becomes 1.6 meter square per kilonewton. So if you simplify it, we can find it out. This gives you 5.208 10 is to minus 4 meter square per kilometer. This is the value of MV. Now, what is the ratio of CV, this part? So this part is important. You can just see this part, that then the ratio of CV of sample M to N. So you can easily calculate. You know the relationship between hydraulic conductivity, MV, gamma W. So what is being asked is the value of CV for sample M divided by CV for sample N will be equal to K value for this sample M, where K is called the coefficient of permeability, divided by MV for sample M into gamma W. Similarly, the value of CVN will be the coefficient of permeability or hydraulic conductivity, which you call it, for sample N divided by MV for sample N into gamma W. So it is going to be Km into MV N, this will go up, gamma W will get cancelled. So MVN and denominator will be coefficient of permeability of sample N into coefficient of volume compressibility for sample M. So very simple way you can find it out. Now, the hydraulic conductivity of sample M to N is 0.125. So this value is 0.125 multiplied by MVN is already 5.208 into 10 raised to minus 4, and the value of MVN M is calculated at 6.878 into 10 raised to minus 4. So 10 raised to minus 4 in numerator and denominator gets cancelled. So I can calculate this value and get the answer. So let us have our calculator, and 5.028 multiplied by 0.125 multiplied by 5.208 divided by 6.878. The ratio is coming out to be this. If you calculate it, the answer you are getting it 0.094 up to 3 decimal places. So the ratio of CV of sample M to N will be 0.0946. So this is the solution. Friends, so we have solved the problems. If you see my previous video, lot many problems I have solved on consolidation settlement. How to compute the consolidation settlement? The consolidation settlement formula is known to you, and it is very, very easy to calculate. So I will take some of the problems in my next video, which you will be getting it shortly. So the consolidation settlement, you know it, it is the compression index divided by 1 plus E naught into thickness of the clay layer into log of overburden, effective overburden pressure plus additional effective pressure at the midpoint of the layer divided by sigma naught prime to the base 10. So for normally consolidated clay, you can use the consolidation settlement, and CC you can find out from the one-dimensional consolidation test by performing in the lab over the clay sample. You can do it very easily, or you can find out by using the empirical formula for the site soil 0.009 liquid limit minus 10. So this is the empirical relationship. This also you can use it, or there are many other empirical relationship that can be used, or from the laboratory consolidation test, 1D test, you can find out CC. So in the next video, I will explain to you. I can also explain to you how to calculate SC for over consolidated clay, how to find out over consolidation ratio, etc., etc. Though I have already done it in my previous videos, but I will once again do it. Thank you very much.